AI isn't thinking, it's just guessing. And it's tricking millions of people into believing it's conscious. Here is the massive optical illusion happening behind your screen right now. We're going to pop the hood on the AI systems we interact with every single day and really understand the mechanics underneath. We hear about AI literally everywhere right now, in the news, at work, just talking with friends, but how many of us know what's happening behind the screen when we type a prompt and get a surprisingly human-like response? Today, we're going to break that down completely. Okay, let's dive right in and bust a common myth right off the bat. When we see a chatbot write a beautiful poem or solve a complex coding problem, it is incredibly tempting to think that these systems possess a human-like brain, or that they're thinking the way you and I do, but they don't. They don't think like humans at all. They're built on incredibly complex math and probability. It's essentially a highly advanced statistical illusion. And understanding that, that's the absolute key to mastering how we use these tools. So, here's our roadmap for this video. If you like this video, please like, share and subscribe my channel at Cyberudan8, and it give motivation to create videos like this. First, the language prediction engine. Second, the transformer architecture. Third, pre-training the model. Fourth, applications and inherent flaws. And finally, fixing LLMs with RAG and fine-tuning. Alright, let's jump right into section 1, the language prediction engine. You've heard the acronym LLM tossed around lately. Large language models, or LLMs, are highly advanced deep learning models specifically designed to understand, process, and generate human language. But don't let that word understand trick you into thinking of human consciousness. At their very core, these models are essentially highly advanced statistical engines. Their whole existence is built around analyzing vast amounts of text and recognizing mathematical patterns within it. So how do they create the text you see on your screen? Well, rather than forming conscious thoughts or ideas, they generate text simply by assigning probabilities to sequences of words. They are continuously sampling what the next word should be. Think of it like the autocomplete feature on your smartphone, but scaled up to a virtually unimaginable level of sophistication. It looks at the words that have already been written, calculates this massive probability matrix, and mathematically decides, okay, based on my data, this specific word is the most likely one to come next. And it does this again, word by word, in fractions of a second. Which brings us to section 2, the transformer architecture. The reason today's LLMs are so incredibly capable compared to the AI from just, say, 10 years ago, boils down to a structural breakthrough called the transformer architecture. And the secret sauce inside this architecture? It's a groundbreaking mechanism known as self-attention. This was literally the key that unlocked modern natural language processing. The contrast between the old way and the new way is huge. Older basic algorithms might just peek at the last word or two to guess what comes next. And as you can probably imagine, that leads to a lot of nonsensical, disjointed sentences. But self-attention, it allows the model to look at every single word in a sequence simultaneously to determine context. It evaluates how every single word relates to every other word, capturing what we call long-range dependencies. This means if a sentence starts with a specific pronoun, the model remembers and weighs that perfectly when predicting a verb 3 paragraphs later. It's exactly why the output feels so remarkably cohesive. Moving right along to section 3, pre-training the model. Now, an LLM isn't just born smart. It must be taught. During pre-training, the model is fed colossal amounts of text. We're talking trillions of words here, comprising vast swaths of the internet, millions of web pages, digitized books, articles, you name it. The model's job during this phase is incredibly simple. Look at a piece of text, hide the next word, guess what it is, and then check its answer. It does this billion and billions of times. By simply learning to guess the next word correctly, across all these diverse examples, the model begins to internalize grammar, facts, reasoning patterns, and general world knowledge. It's all just a brilliant byproduct of a massive mathematical guessing game. Alright, Section 4: Applications and Inherent Flaws. Because of this predictive nature, LLMs can execute incredibly complex natural language processing tasks simply by framing them as word prediction problems. And these core tasks directly map to real-world applications. When you ask an AI to summarize a document, for instance, it's just predicting the most likely words that form a summary of the text provided. This exact same mechanism powers sentiment analysis and question answering. In the real world, this translates to the running modern search systems, driving enterprise workflows, assisting developers as coding co-pilots, and even operating as autonomous AI agents. All these incredibly diverse applications are ultimately rooted in that single foundational trick: guessing the next word. But of course, there's a catch. Despite their immense power, LLMs have inherent flaws tied directly to how they're built. First off, because they rely on static training data, meaning the data they ingested during pre-training stops at a certain date, they inherently lack up-to-date info. Second, out of the box, they can't easily access your secure, private enterprise data. And finally, and this is the famous one, they are prone to hallucinations. A hallucination is when the model confidently generates content that is completely factually incorrect. Remember, it's a statistical engine designed to sound plausible, not a factual database. If the most mathematically probable next word forms a false statement, the model is still going to output it with absolute total confidence. So how do we fix this? That brings us to Section 5, fixing LLMs with RAG and fine-tuning. The first major technique developers use to overcome these limitations is called fine-tuning. Think of pre-training as giving the model a broad general college education. Fine-tuning then is like sending it to a specialized graduate school. Developers carefully adjust the model's internal mathematical weights using a smaller, highly curated dataset. This allows the LLM to perform much better on specialized tasks, things like drafting legal documents or writing medical summaries. Or it can help it adopt a very specific, branded tone of voice. Furthermore, to fix that static data problem and combat those pesky hallucinations, developers use Retrieval-Augmented Generation, or RAG. RAG involves hooking the LLM up to fresh external databases. So, when you ask a question, the system first retrieves the most current relevant information from an external database and then feeds that factual evidence straight into the LLM. It essentially forces the model to base its next word predictions on actual grounded data, rather than just relying on its internal memory. It is a real game changer for making these systems reliable for everyday business use. We've covered a ton of ground today, looking at the math, the architecture, and the tuning techniques that make LLMs work. But I want to leave you with a bit of a provocative thought to chew on after this video. As these statistical engines get better at mimicking human understanding, where exactly is the line between mathematical probability and true knowledge? If an AI can perfectly predict the right answer, explain the context, and solve a problem just by guessing the next word, does it even matter that it doesn't think? It's a fascinating question, and for sure it's one we are all going to have to grapple with as this tech continues to evolve. Thank you so much for joining me for this video, and keep questioning the mechanics behind the tools you use. Hope you enjoyed this video. Tell me about your favorite part in the comments, and don't forget to like, share, and subscribe for more exciting content.